Alright, so in the last video, we introduced the binomial cases, the binomial formula, and did one example. This is just going to be practicing that binomial formula. So again, I'm going to use the binomial formula because I think it's just good so you understand what's going on. And then again, it is required that we teach it with the master syllabus. But if you want to use the calculator and you figure that out, go ahead. Alright, so the first example here is suppose a test has 16 multiple choice questions. Each question had 5 possible responses, so 5 meaning 5 picks. They can pick A, B, C, D, or E. One of those is the correct answer. One of those is the incorrect, or 4 of those are the incorrect answer. Suppose a person guesses when answering each question, assuming no question is left blank. Right? They are independent events because what you do on one question shouldn't affect what you do on the next question, especially if you're just randomly guessing. And so X is going to represent the number of questions guessed correctly. So N would be 16. They're going to try on 16 questions. Probability of success, well, multiple choice question, there's one correct answer, right? In my choices A, B, C, or D, or E, one of those is the correct answer. 4 of those are just, again, what we call foils. And so the probability that you guess a question correctly, well, there's a 1 in 5 chance, or 0.2. 20% chance you guess a question correctly. Q would be, well, suppose A was the correct answer. There's your 1 out of 5, that's correct. It means there were 4 other ones that you could pick that were wrong, right? So you had 4 out of 5 chances to get it wrong, which is 0.8, 80% chance of guessing it wrong. Right? And so there is my binomial. Right? You can either guess a question wrong or you can guess it correct. Right or wrong, right? That's what makes it a binomial. There's only 2 things that can happen when you're guessing, right? You guess it correct or you guess it incorrect. Right? That's it. And so now we're just going to set it up. So first, find the probability of getting exactly 3 questions correct. So probability of random variable x is 3. So remember the formula. It's combination n choose x, probability of success raised to the x, probability of failure raised to the n minus x, right? This would be the chances that you get it right. This is the chances you get it wrong. This is how many different ways that you could do that, right? There's more than one way to guess 3 out of 16 questions right. Right, you can either guess the first 3, the last 3, or any combination of 3 in the middle. And so the formula does that. Right, so it's combination out of 16 tries, right? There were 16 questions. We're going to guess 3 of the 16, so that's what this is. This is figure out, well, how many ways can I guess 3 out of 16 questions correctly? Then it's the probabilities. Probability of guessing a question correct was 0.2. We're guessing 3 of those correct. Probability of guessing it incorrect was 0.8, and since I'm guessing 3 correct out of 16, I should guess 13 incorrect, right? That's what the n minus x is. I take my 16 minus my 3, and this should always add up to your total, right? This is the number you get right, this is the number you get wrong. If I'm getting 3 out of 16 right, I got 13 out of 16 wrong, right? Then I go and I finish my formula. So I do my combination first, although you could type it in all in one shot, that's fine. This comes out 560, so there's 560 ways to guess 3 out of 16 questions, the order, right, and then the probabilities. Right, and this is the probability of guessing 3 questions right, 13 questions wrong. Right, and there are 560 ways that happens. Multiply it by out, and so the odds of guessing 3 questions correct out of 16, if it's a multiple choice case with 5 possible choices, it comes out to almost 25, 0.2463. So 24.63% chance of guessing 3 questions correct out of 20. Alright, probability of guessing at least 2. They actually like the binomial case with the at least 2 is one of those almost a staple on every final exam for the binomial case. Alright, so probability you get at least 2. Which if you were figuring this out, that would be 2 or more, right? 2 or more, which would be guessing 2 or 3 or 4, all the way up to guessing all 16 correctly. which you would have to fill out your formula 14 times. You don't want to. You don't have time to fill out your formula 14 times. You have to use the complement in this case. All right, so the complement is 1 minus the outcomes I don't want. Well, if I want at least 2, the probabilities that I want to throw away is anything less than getting 2 correctly. Well, that would be the 1 case, guessing 1 question correct, or the 0 case. All right? I don't want the case where I'm getting 1 correct, and I don't want the case where I'm getting none of them correct. And so those are the 2 probabilities I need to find, and then throw them away. So I need to find those and subtract them from 1. Make sure you're careful. I want to find those total and subtract them from 1. So I do have to fill out my formula twice, but this formula 1 and 0 are the easy cases because the combination part's pretty easy. All right, so the 1 case, combination out of 16 questions, I guess 1 right. Well, probability of guessing a question right was 0.2, I guess 1. Probability of guessing a question wrong was 0.8. Well, if I'm getting 1 of 16 right, I'm getting 15 of 16 wrong, or, so I add, probability of getting 0 out of the 16 questions, we get none of them right. Probability of guessing them right was 2 to the 0, because I'm not getting any of them right. Probability of guessing them wrong was 0.8, and I'm guessing all 16 wrong. And so remember, this last one, even though I read out the formula, it's really just that probability of getting it wrong all 16 times. And so these are just 1s. And so it simplifies really nice. Combination 16 choose 1 is just 16 times 0.2 times 0.8 raised to the 15. And then this one really is, that's just 1, that's just 1, so this is just our 0.8 raised to the 16. And I usually just type it out on my calculator at one time. Now if you do it, do this side first, and then do minus 1. Make sure you're careful. Don't forget to subtract it from 1. And then give yourself plenty of decimal places, like round 4 or 5 decimal places so you're not significantly off when you're rounding. And so I just type it in there, though, in one shot. It should come out 0.85926. All right, probability of getting at least 2 questions correct. You really want to use the complement. But you can't forget, you are using the complement, so make sure you're careful. Figure out the 2 cases you want to get rid of, and then don't forget we're getting rid of them, so we're subtracting them from 1. Alright, next example. Alright, Joe likes to play darts. On any given throw, his probability of getting a bullseye is 1 out of 3. If Joe throws 8 darts, what's the probability to get exactly 3? So it means out of 8 tries, he's going to succeed 3 times. Alright, so X is going to count the number of bullseyes. N, he's trying 8 times. Probability of success is 1/3, and leave it 1/3. Do not round that. Probability of failure would be 2/3. Right, if he's excelling 1/3 of the time. Those are non-terminating decimals. Do not write 0.33. Do not write 0.67. Write it 1/3, 2/3, because we're going to raise them to exponents. You're going to be off, and your number is going to be wrong. And when you type it into the computer, you're going to get a wrong answer. Alright, leave them exact. Alright, do not round fractions. No rounding until the end of the problem. So we're looking for the probability X is 3. Alright, so it's combination out of 8 tries. We're going to succeed 3 times. Probability of success is 1/3. Leave 1/3 cubed, because if we round, remember we're taking 1/3 times 1/3 times 1/3, you're rounding 3 times significantly, because we're going to multiply that out. And so it makes the rounding error huge. So do not round. And again, same thing for the failure. You're going to fail 2/3 of the time. And if you're succeeding 3 out of 8 tries, you're going to fail 5. And so again, if you round that to 0.67 or 0.66, you're significantly off 5 times, right, which makes a big, huge rounding error. So do not round fractions. Leave them exact and put them in parentheses. Right? So the calculator follows order of operations. So make sure you're careful with fractions. Do not round the probabilities. And then make sure parentheses. So the calculator follows order of operations. So first thing is 8 choose 3 is usually what I figure out. You can type it on all at once. Just make sure you put parentheses around those fractions. So I usually find my combinations first. So that's 56 times 1/3 cubed times 2/3 to the 5th. And again, I put parentheses. If you don't, what happens, it'll cube the 1 but not cube the 3. Same thing here. It'll take 2 to the 5th, but it won't take 3 to the 5th. So you have to make sure you put parentheses. And then it comes out to 0.2731. Alright, so again, if you rounded, your rounding error will be significant, and when you type it in, you get it as a wrong answer because you have a rounding error. Alright, the last one. I want to do another one of these at least. Actually, this is a problem that I took straight off of an old exam. Alright, I like these, again, like I said, the at least 2 cases for binomials. Alright, probability a certain machine is defective is 0.05. Find the probability in a run of 75 items, at least 2 are defective. Alright, so this time, even though we're looking for defective items, so that's success. So success isn't a good thing, but we want to find the defective items, right? So we can get rid of them, or fix them, or do whatever. So X is going to count the defective items. Run up to 75 items, meaning that's how many they're producing, right? They're producing 75 items. That percent of them tend to come out defective. So probability that you get a defective item is 0.05, which means the probability it's fine, not defective, would be 0.95. Alright, we want to look at the case where probability we get at least 2 defective, which, if you were going to do this straight out, it would be 2 or more, so it would be 2 to 75. You would have to fill out your formula 73 times. I don't want to fill out my formula. I don't have time to fill out my formula 73 times. And so you have to use the complement in these at least 2 cases. So it's 1 minus the probabilities that I don't want, right? Probability that one of them comes out defective or 0 comes out defective. None of them come out defective. Right? And I want to subtract those from 1, so make sure you're careful when you're filling this out. So 1 minus the probability of getting 1, well, that would be combination out of 75, I get 1 bad one. Probability of getting a bad one is 0.5, I get 1 of those. Probability that it's not bad, 0.95. Well, if I'm getting 1 bad out of 75, it means I'm getting 74 that are not. Or, so we add, probability that I get 0 of the 75 are bad. So 0.05 raised to the 0, which again, those are just 1. If you don't want to include those, you don't have to. And then 95. Since I'm not getting any of them bad, all 75 are fine. Alright? And then you fill them out. So 75 choose 1 is 75. I'm getting 1 bad one. I'm getting 74 good ones. And the last case, all of them, all 75 come out good. Alright, so 75 ways to get 1 bad one out of 75. Probability of getting the 1 bad one is that. Probability, if I get 1 bad one, I get 74 good ones. That's the odds I get that. And then the last case is just all 75 are good, right? So all 75 are good, so the odds of that happening is the probability that it's good, 0.95, 75 times. And then type it all out. So again, I type it all out in one shot. If you do them 2 at a time, just make sure you give yourself like 5 or 6 decimal places so you don't round significantly. I type it in all at once so that I don't have to worry about rounding until the very end of the problem. And it comes out 0.8944. Alright, and so that's the at least case. So make sure you understand that. Like I said, this is actually one I took straight off of a final. They like these at least 2 on the final exam. On your own, 38% of the population has the blood type of O positive. If you select 10 of your classmates, what's the probability to get exactly 4 or 5 of them? So if I were randomly picking 10 people in your class, what's the odds that you get 4 or 5? So N is 10. 10 is what you're selecting. You have 2 cases. We want to get 4 or 5 that have the blood type. Probability of success would be 0.38. Probability of failure would be 1 minus 0.38. Right, and then you have to fill out the formula 2 times and add up those 2 outcomes. Alright, so you will have to do it for both of them and add them up. Just make sure, again, you type it out carefully and don't round to the very end. Right, and that's one left for you to do. So that finishes up the binomial cases.